All right, this is group 10 of 11. This group name is the Maybes.
Hi everyone, my name is Anthony. I'm majoring in IT at UNF.
Hi everyone, my name is Yuyin and I major in statistics at UNF. And we are the Maybes.
All right, for this hackathon, we chose the second problem case, and that was to build out an affordability index formula and bring those values to each census tract in Jacksonville, as well as making a dashboard for users to be able to interact with, interpret, and be able to visualize clearly.
We chose this case because we believe we have the skill sets to solve this case, and we wanted to step out of our comfort zone to improve the Jacksonville community in general.
All right, our executive summary. We have endeavored to make a data-driven way to understand the people of Jacksonville and their livelihoods here, as well as what they may face on a daily basis, through a numerical fashion, which would be easily understood. And to do this, we utilized numerous Python packages, the IDE Spider, and for instance, some of those would be MATLAB, I believe, and it was Pandas.
We also intended to use Tableau Desktop Public Edition to generate a map for Jacksonville area with the data we have that provided us.
All right, so the data provided to us by mySideWalk and the City of Jacksonville was ample. There was a lot to comb through, but there are also inconsistencies with it by a category basis, as well as some null values that we encountered as we were working through this. Depending on the category, some of the null values would range up to 30 to 40%, so we would have to find a way to cut those out of the final CSV file we would use at the end. And we ended up choosing the factors median home value, median household income, and houses that were receiving SNAP benefits. All right, so for this project, we used 3 steps to really try to encapsulate our values that we would derive from the data. The first step would be combing through and limiting the sources by seeing which source would have too many null values to compute with even. And then the next step would be determining which sources to use through a k-means clustering method. That would really mean grouping the sources by how they would impact affordability and how they are related to each other. And so with that, we found our 3. And then the next would be to output affordability index values of each census tract to a CSV file, which would be able to be used. And to do that, we would first normalize it or standardize so that everything would fall in 0 to 1, fall between 0 to 1. And then we applied equal weight to each factor in the formula just as a means of standardizing. And so our affordability index would be normalized income plus the inverted normalized home value plus inverted normalized household to a SNAP over 3. Here's the elbow plot that the k-means clustering method that we used output. As you can see here, with the y-axis being inertia and the x-axis being the number of clusters, it recommended to us the optimum amount of clusters being 3 because of how the inertia dropped so harshly once it reached 3 clusters, meaning that there would be, in the clusters, there would be the least amount of variance. And for our performance results, we were able to output these were our affordability index results in a CSV file. And next we have a draft of what our dashboard would look like after inputting this.
So this is the design of our affordability index dashboard. So we will have a heat map with different color coded. So when it has a high affordability index, we will have a darker shade, and when it has like a lower affordability index, it will have a lower shade. And then we'll provide the users with different graphs to visualize and compare the data with each census tract to the affordability index. Then we also provide like the sliders for the users to adjust the weights of each variables with their own preferences. Then we'll generate a result based on our formula to show the user the overall affordability index. So the higher affordability index, which means that it will be a higher possibility the people in Jacksonville will be able to afford housing. So based on the formula, when it has a higher income, a higher inverted home value, when it has a lower inverted SNAP benefits, then we'll have a higher affordability index.
All right.
In conclusion, if we have more time, we'll sort and compare more data, and we will also bring the dashboard to life with more interactions and more features.
All right. To improve this, we would need to further test this formula and bring it to the different cities around America, so that we can see if the results hold up, even regardless of the differing economy and the different characteristics of the cities. But there were some risks involved with using this formula, specifically the weights. We used equal weights, meaning that we determined that each factor of our formula would have an equal impact on the final value, but that may be different. So we would, if we had more time, we would use expert analysis, maybe bring in some results from different reports to weigh in on what our weights should be going forward.
So last but not least, I want to thank each professor and mentors and peers that help and guide us along the way. Thank you so much.
Any questions? Shout out Dr. Dan, Mr. Karthik, Marian, and Baraka.